Thanks everyone for coming. Today I'm excited to talk about how we achieved a sub-second real-time analysis, walking through a performance optimization we made. And I'll show you how we did what every developer dreams of, taking a legacy code system and rewrite it from scratch. It's not a joke. But before we dive into our journey, let me introduce myself. So, my name is Nir. I'm working as a software engineer at Riskified for around 4 years. In a minute, I will explain why I say around. I moved to Lisbon a year ago, and I really like here. The people, the environment, mostly the good wine. And I really like adventures and traveling so much that in 2022, I decided to take some time off that turns into 2 years of traveling around the world with my wife. 5 continents, great journey. But we will not talk about this today because that's completely different journey that didn't last less than 1 second. So that's me. What will we talk about today? I will give you a quick introduction to Riskified, who we are and what we do. We will walk through Riskified journey over the year from the very first beginning, how we start our system as a monolith and eventually built our new microservice architecture to meet our performance need. And during this journey, we'll see how the business requirement that changed along the way shaped our architecture compared to the legacy architecture, and we see also the challenges that we face along the way and how we overcame them. And finally, we will break down how we achieve the sub-second latency. And of course, we will wrap up with some time at the end for a question. So Riskified, what is Riskified and what we do? So Riskified is a leading e-commerce fraud prevention and chargeback protection company. We provide machine learning-based solution designed to help online retailers to enhance their fraud detection, improve customer experience, and maximize revenues. And today our focus will be on our main product that's called Chargeback Guarantee, that serves actually as a foundation to many of our other products in Riskified. So what is Chargeback Guarantee? Chargeback Guarantee is our core product that provides comprehensive protections against fraudulent chargebacks for e-commerce merchants. With this service, Riskified takes the financial liability on any fraudulent chargebacks, guaranteeing all the transaction and proof within our system. So how does it work? So imagine you're checking your monthly bank statement and suddenly you noticed, this is your monthly bank statement, and suddenly you noticed a payment you didn't make, like this. And what will you do? You will probably call to your bank and ask to dispute the charge and request a refund. The bank will ask from you for some details, will investigate the case, and will return the money to you. But what happens behind the scene that you might not know? So when a customer contacts the bank, then the bank reach out the merchant where the transaction was made and ask them to return the money. And this what makes the merchant's responsibility to handle any potential fraud in their system, even though they simply want to focus on selling their products. And that's exactly where Riskified steps in. So at that point, a merchant that works with Riskified, passing along the dispute information, and we take the full responsibility and reimburse the merchant so he doesn't suffer from any financial loss. And this allows the merchant to operate with confidence and to focus on growing their business while we take the risk by ourselves. So here we can see an high-level flow of our analysis within our Chargeback Guarantee product, from the moment merchant transaction enters to our system to the final decision. So typically, the merchants send us some basic information such as email, name, address, and then we enhance this basic information in step we call enrichment by pulling additional data from both internal and external data sources. These sources provide us some crucial data that can affect the final decision, such as customer history, risk signals, and some more data. We will talk about this data source a bit more in detail in the next slides. In the next step, we calculate feature. Unlike what we typically mean when we're talking about developed features in product, here features refers to the input fed into our machine learning models. But what are exactly features? Features are pieces of data that calculated based on the data from the previous stages, such as the enrichment and the merchant transaction. And what's important to understand that these features are the input to the next step in the process. So in the next process, the decision, the calculated features got as an input to the machine learning models, and it outputs a decision based on its current input and its training data, and the decision can be either prove that we say this transaction is safe and we're guaranteeing this transaction, or even decline that we said, okay, there is a risk, this transaction should be declined. So to this process we call analysis. So let's take a look at the journey we went over the year and see how this chargeback product has some changes along the way. So in 2013, Riskified started developing its chargeback guarantee product within the monolith. Initially, the architecture worked fine, but as we added more features and more capabilities, the system became increasingly complex. So in 2020 and the beginning of 2021, we started to extract some important components, such as the analysis itself and the feature calculation, to different dedicated services, which improved the performance and the scalability and the flexibility of the system, and it helped for that time. But then, in 2021, December 2021, a new business requirement emerged, demanding sub-second real-time analysis. So let's take a look at those requirements. So the first key requirement was to have fast analysis, sub-second real-time analysis. In e-commerce, speed is important, and for some industries, it's even critical. Think about it. You're about to purchase a flight ticket and you have to wait a long time. You may reconsider the website or your purchase, and you may leave the website before completing it. The second key requirement was to expanding our reach to as many industries as possible, such as flight tickets and food delivery, such as other industries that needed a really, really fast analysis. And by supporting these different industries, we're expanding our reach to more customers and growing in the e-commerce market. And the third, that you might think that, okay, it's not a new requirement, but having said that we need a fast analysis system that knows to process and process and handle large transaction volumes, our system should be reliability and scalability during this processing. So at that time, we look at our architecture and we try to understand if we can meet those requirements with what we have back then. So at that time we call it our architecture, now we call it our legacy architecture. And let's see what the challenges we face with. So as I said, the monolith was written in Ruby based on some old versions that didn't support concurrency. It also made it very difficult to scale. That made our system very slow. Having said that, initially we had a very high latency, and although we managed to improve it over time, we couldn't reduce to the desired target, and it makes it even difficult during the time and the complexity of our system. And one more thing, that we had a limited end-to-end visibility in our system. We couldn't monitor our analysis from first to start, which made it hard to identify latency issues or any other problems in our system. And our system was relied heavily on the database because of many time-consuming back and forth queries to our database in order to fetch some related data to this transaction and to store the transaction state itself, which make it very slow, further increasing latency. So the challenges that we faced, together with our business requirements, highlighted us the need for a change. So we understand that there is a need to break free from the monolith. So in January 2022, we started to work on our new architecture, new microservice architecture, and we tried to work with some core features to go launch as fast as we can. And in July 2022, we went live with our first merchant. That was a significant milestone for Riskified, a system that handles transactions in less than 1 second. And we will focus more about this part and how we achieve it in the next slide. But before that, in 2022, between 2022 until today, we added more and more capabilities to match our legacy architecture and to migrate more merchants to our system. So, how did we achieve the sub-second latency for our real-time analysis? Okay, so, just a second. So, before we broke down the monolith, the merchant transaction communicated directly with Riskified API. So our first step was to extract the analysis component to a dedicated service within our new microservice architecture, like you can see. And this gave us several key advantages. It helped us to define efficient and clear API separated from the merchant transaction API, which had been very challenging within the monolith. We gained from it the ability to scale our analysis independently without affecting other components in the system, and the simplified code in the new service made it very easy to maintain and reduce the complexity of our code base. It provided us the flexibility to deploy any updates independently as well, would reduce the deployment risk and minimize downtime. And also we were able to allocate resources more effectively, reduce the insufficiencies, and improve the performance. So we can see that only from separate this service, this component, this main flow to another service, we improved the performance and we gained a lot of benefits. And another crucial part over creating the new services was the adoption of gRPC communication between our services, which improved the performance and lowered the latency by using HTTP2 over the hood to handle multiple requests over a single connection. And also, it provides us strongly typed contracts, ensures efficient, clear, and error-free data exchange, and with its cross-language support, it helps our service to communicate with each other, even though they're implemented in different languages. In the next step, we focused on maximizing parallelism to reduce the processing time and to improve the scalability without affecting other components in the system and without affecting the system stability. So how we did it? So we processed the data sources, those that I mentioned before from the enrichment part, we processed them in parallel rather than sequentially, which made the analysis much faster and handles large transactions volume much more efficiency. And by structuring the parallelism of the data source in levels, we ensure the correctness because we did it based on their interdependencies. So we ensure the correctness of the code, and we maximize it by the parallelism and improve the performance and lower the latency. Over that, we implemented timeout budgeting mechanism at each stage, ensuring none of the stages delays the entire process. So if a stage exceeds its timeout, we proceed in a process and handling the missing data later. For missing features from the feature calculation step, we set default values and predictive model to preventing the whole process from failures or any delay on the process going. And a pivotal part of our journey to reach the real-time sub-second analysis was the transitioning of our analysis to a fully stateless architecture. So as I mentioned earlier, one of our challenges, maybe the biggest one, was the heavy reliance of our analysis on the database because of many time-consuming back and forth queries to fetch some related data, to store the transaction state, and it was really hard to identify some issues using what we had this time. So in the new architecture, in the new service, we fetch instead of fetching the data from the database, you got the data as an input, and we store the transaction state after the analysis rather than during it. This made the processing of large transaction volumes scalable, reliable, while reducing memory usage and storage needs. And that was a really game changer for us at that time because this separation lowered a lot the latency and improved many aspects of scalability as well in our system. And a last key aspect of our journey was the implementation of a robust monitoring system. So it's not that we didn't have at all monitoring system in our legacy architecture, but it was limited and it was really hard to identify issues and to optimize the performance. So in the new architecture, we used Grafana and Prometheus and some other tools to enhance our monitoring system, and we added a detailed metrics to any stage in our system, including end-to-end, and for every step in the analysis flow, including the enrichment, the feature calculation, decision-making. And this allows us to set a real-time alert, allowing us to investigate latency issues. And by continually monitoring these metrics, we can quickly resolve problems and to ensure optimal performance and the reliability on our system, of our system. So, as someone wise once said, new is always better. Yeah, maybe not always, but for our case. So if we take a look on the decision we made on our journey, we can see that they shape our architecture to meet our performance need and to meet our requirements, and we gain from it a lot of other benefits. So, in terms of stack, we could choose the most suitable and cutting-edge technologies to our performance needs. So we use Scala and Node to improve the performance and scalability and the concurrency of our system. The microservice that we use versus the monolith that help us to separate the concern of every component and also improve the performance. And we use Grafana and Prometheus, like I mentioned, to enhance our monitoring system. And in terms of features, so now our system is much more modular. We can use it for offline processing and for research usage. We're using Spark and Databricks. Our system now is much more resilient with counters that have metrics for every part, even small part. We can see even small functions in our system. And the separation from the database gave us the ability to maintain our system much easier. And the last and maybe the important one, from business perspective, we reach our P99 of 500 milliseconds, much less than 1 second, and customer satisfaction. Thank you. Question? Yeah.
I will perhaps ask. Thank you. Thank you very much. Thank you very much. I will perhaps ask a ridiculous question, but I will ask it. So, assuming I'm buying something, for example, by Amazon, okay? I choose what I want to buy. I have the basket of what I want to buy, and then Amazon is giving the possibility to choose how do you want to pay what you buy.
Yeah.
And then, for example, I choose the Visa card, and then I introduce all the data of my Visa card.
Yeah.
So, where is the risk? Because the bank will acknowledge the payment, and if I'm delivered, the payment is not done until the delivery is not done. So where is the risk? Is the risk from a false buyer for a false Visa card, or where is the risk?
Yeah, so there are many ways of frauds that can happen. One simple can be that someone steal your credit card and just use it. Some other can be that someone take your details on your of your credit card or the details of your account. There is many kind of frauds.
And you can detect that?
We can detect it.
Wow.
That's what we do.
And so your customer are banks?
Our customers are the merchants.
Are they?
The merchants. For your example, Amazon.
So you have as Amazon as customer and banks as customers.
So yeah.
Congratulations.
Thank you.
I do have one question as well.
Yeah.
You mentioned that you have multiple data sources.
Yeah.
And maybe this is getting into a lot of like the secret of the sauce, but like what are the data sources? Are they mostly internal? Do you have also external data sources?
Yeah, so as I mentioned, we have also both internal and external. I will not go into details of all of them because there are a lot, but some of them enhance the information, the transaction information by putting some customer history that you got and some data on the information on your name, on your phone, some details like that.
Okay, so you have a database full of data from everyone.
Yeah.
Right. If I request to delete my data.
We support it. Yeah, we are.
Any other questions? Yeah. A tricky question.
So Nir, you mentioned that you implemented time budgeting for different steps in enrichment phase. So if some phase hits the timeout, and we don't get this data, does it affect the analysis somehow?
So it did affect, it can affect, but we handle this missing data with some smart mechanism that know how to work without this data. Is that answer to your question? Yeah.
Do we have any mechanism for late arriving data to get it after we get initial decision?
For example?
So we didn't get this data initially,
Yeah.
and we get the decision, decline. But then we get this data.
You mean if we fail to fetch this data?
Yeah.
So we have a few processes, but usually we're getting the real-time data on this transaction. Yeah. We have some offline processing for that as well.
Okay.
Is your response always like false or true or false, or is it a score somewhere in between?
So the childbirth guarantee is work with decline or approve. And of course, we have some fallbacks but also the return declined or approved. But we do have some score solution separated. Yeah.
And what happens if it's just in between? Is it going to be approved or is it going to be declined?
So it will always have like decision because we have a threshold, and all that the score was behind the threshold or.
So you can't have like someone, maybe it's a frozer, maybe it's legit?
No way.
Never.
We do have some mechanisms without like 3DS or SMS.
Yeah.
Yeah.
So the less legit the people, the buyer is, then the more control you will add to the process.
Can you repeat it?
The less legit the score will be. I mean, the less the score will be,
Yeah.
the more control you will be able to add, or maybe the merchant. That's not your role, maybe. To add more control to the payout process.
What do you mean control?
Control is like, if you know that a buyer is a froster, you will add as much control you need to make sure it's not a froster anymore. But if you know this customer, you will just make it easy for him to have a frictionless.
We do have some mechanisms, like you said before, about customer history, so we know a little bit.
So yeah,
the customer. We integrate it within the enrichment process, so it will affect your eventual score.
All right. And do you have a back end for the merchant to be able to see the score?
Yeah.
Or good.
All right. Thank you.
Thank you very much.
Oh, wait. Another question? There. Sorry.
Okay. I can get it more and more. It's okay.
Thank you. Hello.
Yeah.
Hello. It's in front. So when I receive an email of a merchant, there are some photos of different products. Assuming I click only to see what is the product and the characteristics, it's possible that when I click, there is a message which is sent to the sender of the email, which say to the merchant, this man is interested by this product, he is looking at this product. So can you prevent this from sending such message?
Well, it's not our job.
Okay.
There might other products that do it, but not risky.
Okay. Thank you.
Yeah.
All right.
Okay. Thank you very much.
Yeah.